The standard corporate training loop operates like a well-oiled machine. Employees click through a sequence of modules, pass a required multiple-choice quiz, submit a brief post-course survey, and return to their desks. This is a chart showing two metrics over time. The completion rate of the training modules smoothly hits 100%, while the actual real-world productivity of those same employees remains completely flat. Standardized multiple-choice tests are highly efficient to write, administer, and score. They guarantee grading consistency across thousands of users, but they are entirely optimized for administrative convenience, not for measuring human behavioral change. This creates a central paradox in learning design. A multiple-choice test primarily proves that a user is proficient at navigating multiple-choice tests. Passing a 100-question history quiz on rotary wing flight does not make a person qualified to sit in the cockpit and lift a helicopter off the ground. This brings us to a pervasive tension in the industry. Why do instructional designs that function perfectly within the testing environment consistently fail to yield measurable workplace impact? True evaluation requires abandoning the final exam approach. Instead, we have to build a 4-tiered telemetry system. This architecture measures design functionality at the base, then knowledge acquisition, skill performance, and finally real-world transfer at the top. Shifting from a passive testing mindset to an active telemetry mindset provides a diagnostic roadmap, identifying exactly where a program is succeeding and where it is breaking down. We start at the foundation of the evaluation stack, design functionality. Before assessing the learner, we have to answer a more basic question. Does the digital resource actually work? The primary obstacle here is the curse of knowledge. Subject matter experts spend months organizing complex information until the intricate machinery of the content makes perfect logical sense to them. Because they are so close to the material, they lose the ability to see interface friction. But a novice learner is starting from scratch. What is perfectly clear to the expert will often register as a muddled mess of confusion to the target audience. The protocol to identify these blind spots is live usability testing. This only requires recruiting a small cohort of 3 to 5 actual target learners. During a screen sharing session, the learner is instructed to think aloud as they navigate the course. The observer must remain entirely silent, watching where the user gets stuck and intervening only if the learner faces a total roadblock. Relying solely on post-course surveys, often called smile sheets, collects reaction data far too late in the development cycle. By the time a survey alerts you to a problem, the resource is already polished, making it difficult to correct core structural flaws. Running these early, silent observations on a handful of real users prevents an organization from unknowingly scaling a broken interface to thousands of employees. Once the interface functions seamlessly, we advance to Layer 2, knowledge acquisition. Here, we need to know if the target audience is actually learning the right things. Let's examine a standard multiple-choice question about an angry customer. 3 options use aggressive language, while 1 offers an empathetic response. A user without expertise can rapidly eliminate the aggressive distractors using basic logic, arriving at the correct answer by default. This dynamic defines a recognition assessment. The correct answer is already on the screen, requiring low cognitive effort from the learner to simply spot it among obvious falsehoods. The superior alternative is a recall assessment. By forcing the learner to generate their own solution from scratch in an empty text field, the evaluation mimics the stakes and cognitive load of the real world. The immediate hurdle with recall assessments is scalability. Judging an open-ended response requires human review, which is a labor-intensive and costly process. If a program must rely on recognition formats for administrative scale, those tests require rigorous engineering. They need dense scenario-based context, weighted grading scales, and the complete elimination of obvious, mediocre distractors. Knowledge testing has to be constructed to force critical thinking. The assessment must guarantee that a user is actively applying complex logic, rather than just identifying the path of least resistance. We now reach Layer 3, skill performance. Knowing the right answer is different from executing the right behavior. So we must ask, can the learners actually perform the targeted actions? Observing and evaluating complex, nuanced skills introduces significant friction. It requires subjective human judgment, and human graders are notoriously inconsistent. Studies on subjective evaluation show that even experienced judges will issue harsher sentences right before lunch than they do earlier in the day. Extraneous variables constantly skew subjective feedback. To mitigate this inconsistency, evaluators must externalize tacit, unwritten skills into rigid frameworks. This means defining specific performance behaviors within objective checklists and rubrics. When expert graders are entirely unavailable, a digital self-evaluation interface provides a scalable solution. The learner generates a response and then manually verifies their own steps against a rigorous checklist of expert criteria. These explicit rubrics can also be deployed across peer-to-peer and near-peer networks, allowing learners to provide reliable, highly structured feedback to one another without overwhelming the instructional team. A professional skill cannot be accurately measured across an organization until its invisible quality standards are codified into a visible, verifiable interface. Finally, we ascend to the ultimate layer of the stack, real-world transfer. This answers the most critical question in the entire process. Are employees actually applying these behaviors back on the job? In the Kirkpatrick evaluation model, this level 4 impact is the rarest metric organizations track, yet it is the only true measure of an instructional design success. The gold standard for measuring real-world transfer is an A/B testing cohort. You split an audience in half. Only cohort A receives training. A significant performance divergence between the groups provides clear evidence that the intervention drove the gain. However, many corporate environments lack direct, easily divisible revenue metrics. In these cases, evaluators must rely on tracking proxy signals. A proxy signal is an observable operational metric, like a measurable drop in internal help desk ticket volume or a sudden reduction in safety floor incidents immediately following a new training rollout. When quantitative data is entirely absent, the final fallback is Robert Brinkerhoff's success case method. You deploy a brief survey to identify the extreme outliers, the absolute best and worst performers, and then conduct qualitative interviews with them. Investigating these extreme outliers through structured conversations reveals the hidden organizational truths and systemic friction points that explain exactly why a module thrived or failed in the real world. With the entire 4-tier stack complete, we have a comprehensive evaluation architecture: functionality, knowledge, performance, and transfer. But this is not a static endpoint. The data collected at the top of the stack cascades back down to the foundation, creating a continuous feedback loop. Usability testing flags interface friction, rubrics measure human capability, and proxy signals track reality. This effectively replaces the concept of a passive, retrospective report card with a dynamic, forward-looking telemetry system. Yet, collecting this wealth of data remains entirely useless unless the organization is willing to act on it, utilizing those insights to continuously re-engineer and update the learning experience. Effective evaluation captures the precise, rigorous data required to iterate on a design until human behavior actually evolves.